Welcome. This is the Eco-Modernist Podcast. Our philosophy is based on sound science and free from the outdated dogmas of the 20th century.
Hi, this is Gabe and Rick.
And this is Rick Maltese.
And this is the Eco-Modernist Podcast. There's no greater question in our time than what effects climate change will have on our collective future. Just how bad it could get and how we should deal with this potentially existential problem. This podcast deals with the head of a group of scientists on their report for the National Academy of Sciences on the possibility that our planet could slip into a hothouse Earth and how we are to avoid this outcome, which could be monumentally catastrophic.
Will Steffens has a long history in international global climate change research, serving from 1998 to 2004 as Executive Director of the International Geosphere-Biosphere Program in Stockholm, Sweden, and Executive Officer of their Global Change and Terrestrial Ecosystems Project. He is also the former Director of the Australian National University Climate Change Institute. He has served as Science Advisor to the Australian Government Department of Climate Change.
Welcome to our show, Will. It's a pleasure to have you on board.
Great.
The Earth system could potentially follow many trajectories. What might those trajectories be?
Well, what we do is we put those individual trajectories into two broad pathways, and it's a bit easier to understand when you do that. One of the pathways, a set of trajectories, are the ones we're on now, which is going toward a much hotter world, a much less biodiverse world, and a world that's going to be much tougher, we think, for humans. So this would be the trajectories, for example, of the IPCC that lead you toward a 3 or 4 or 5 degree temperature rise by the end of the century. The trajectories from the biodiversity community of extinction rates reaching 100 to 1,000 times background level and so on. Then there are another set of trajectories which fall into a broad pathway which we call stabilized Earth, which is where we human societies play a much stronger stewardship role in terms of getting carbon emissions down, in terms of managing biospheric sinks of carbon, in terms of getting extinction rates down by taking pressure off the biosphere and so on. Now, within each of those broad pathways, there are a number of precise trajectories which could be followed. So what we're saying basically is that there are many trajectories, but basically they're going to fall into one of those two pathways, and probably not any in between.
Okay. In the report, it is stated that the stewardship of the entire Earth system must include decarbonization of the global economy, enhancement of biosphere carbon sinks, behavioral changes, technological innovations, new governance arrangements, and transformed social values. Could you extrapolate on that a little?
Saying here is it needs to be a comprehensive change of direction for what we call the human enterprise. And there are obvious things we need to do. That means, of course, we've got to get carbon out of our economy. There are already ways that we can do this, particularly in the electricity sector. There are other ways that are being developed very rapidly in the transport sector in terms of electric vehicles, more high-speed rail transport, and so on. So we have the opportunity to be on the pathway there to decarbonize the economy. In terms of biosphere carbon sinks, they're really important. Examples of these are the tropical rainforest, particularly the Amazon rainforest, the vast boreal forest in the northern hemisphere, and basically more generally soil carbon in the land biosphere, and so on. These are important because they absorb a lot of the carbon that we're emitting. In fact, only about half the carbon we actually emit stays in the atmosphere for a long period of time. The other half is absorbed roughly equally by the ocean sinks and the land sinks. But these two sinks are weakening in a relative sense compared to our rate of emissions. And some of these particular biosphere sinks, like the Amazon forest, are also being eroded and degraded through deforestation. So these are things that we really need to look after much better to make sure that we have well-functioning biosphere sinks that can assist us in stabilizing and then bringing down the amount of carbon in the atmosphere. We need behavioral changes. We need to change the way we move around cities, for example, from private vehicles to active transport, cycling, walking, and to using public transport. And that requires also changes in where and how we live and so on. New governance arrangements, that's one that a lot of governance scholars are working on already. There's a big project called the Earth System Governance Project. And the idea there is that the present system of government just simply isn't working because it's the one that's leading to ever-increasing emissions, ever-increasing erosion of biosphere sinks, increasing rates of biodiversity loss, and so on. So there's a lot of research also then on how new governance systems can be set up. The biggest issue there, I think, is transnational governance issues. We have one Earth system, we have one climate system, we are one species, so we are going to have to make a transition towards setting up better systems by which we can govern our own activities at the global level. That we have to put a much higher value on the well-functioning biosphere, on a stable planetary system. We have to put a much stronger emphasis on more equity across human systems as well. So basically, when you put all of those things together, what we're talking about here really is a transformation from the sort of post-World War II high-consumption, high-paced societies that we have today toward ones that do a much better job of looking after social values, equity values, the biosphere, and becoming stewards of the planet on which we live.
You say that there is a planetary threshold in the trajectory of the Earth system that, if crossed, could destabilize the climate that is inhospitable to humans for tens to hundreds of thousands of years. What exactly do you mean by that?
Well, here we're talking about a series of tipping elements in the Earth system that together could form a cascade for generating a planetary threshold. For example, if you tip the Amazon forest and self-reinforcing feedbacks within that basically convert it from a tropical forest to a savanna or a grassland. Same thing with some of the big systems of ice on the planet. Once ice melt on Greenland reaches a certain rate, it's likely to continue because as that ice sheet melts, it becomes lower in altitude, it gets into a warmer climatic zone which increases the melting further, and so on and so on. So it's these tipping points, and once they can act like a row of dominoes. So once you start tipping one, you start tipping the others as temperature goes up. Once that process gets started, it may be impossible to stop. And that it gets into a warmer climatic zone which increases the melting further, and so on and so on. So it's these tipping points. They can act like a row of dominoes. So once you start tipping one, you start tipping the others as temperature goes up. Once that process gets started, it may be impossible to stop. And that's the sort of planetary threshold which is actually formed by this tipping cascade. If we actually activate that and can't get back from it, we would go to an Earth at least 4 or 5 degrees hotter than pre-industrial levels with much higher CO2 levels and much less ice. The Earth can bring that back to a cooler climate, but the processes, which are the carbonate and silicate cycles, take hundreds of thousands of years to pull that carbon out of the atmosphere. So that's actually what we mean about the planetary threshold. It's really formed of a bunch of individual tipping elements that could form a cascade.
You said silicate cycle. You sort of got past me on that one.
Yeah, sorry. The weathering of rocks, which contain a lot of carbonates and silicates. Think of sand. Sand is a silicate material. When they weather slowly through rain and types of erosion, they actually absorb CO2 from the atmosphere to form calcium carbonate. And also silicate also has calcium carbonates in it. That is a process that historically in Earth history has taken carbon out of the atmosphere in large amounts. But it's slow. On a human time scale, very slow. So it takes a long time for it to actually pull the CO2 out of the atmosphere.
You speak of a threshold. Do we have enough information to grasp where that line is? And if a threshold is crossed, what are the implications, especially for the well-being of human societies?
Yeah, we don't know precisely where that lies. We're pretty certain that that threshold doesn't lie as low as 1 degree Celsius temperature rise, which we're at today, and probably not at 1.5. At the other end of the scale, it looks pretty likely that if we hit 3 degrees, we will have crossed that threshold. So somewhere between 1.5 and 3 degrees is a reasonable estimate now of where it lies. In terms of what this actually means for the well-being of human societies, well, all estimates are is that a 4-degree world is going to be a tough one to live in. Obviously, it'll be much harder. Populations will have to move away from the equator and the subtropics. They'll simply be too hot to exist in. The big agricultural zones of the Earth will be threatened with heat, changing rainfall. Central USA, Northeast China, Western Europe, and so on. The water system will be changed. Rain will be falling in very different places. Droughts will be worse in drought-prone areas, and so on. When you put all that together, it's a really tough world to live in, and it's very likely that we won't be able to sustain the populations even that we have today of 7.5 billion people.
Well, let me ask you this. Is it a matter more of unknowns, or is it more a matter of political will?
I think there are a lot of knowns already in how the Earth system behaves, so it's not a matter of known unknowns. It's a matter of we know what those risks look like. The science is getting better, and we're getting a better handle on where they might lie. I think it's a real matter of political will, values, what we think is important in life, and so on. So it gets to some pretty fundamental issues for human societies.
What human actions could steer the Earth system away from the potential threshold and maintain somewhat normal conditions?
Yeah, well, I think obviously we've got to get carbon emissions down very, very rapidly. That's already on the agenda. We've just had a big IPCC report on that. But also we have to maintain and enhance these biosphere sinks. We've got to become better stewards of the Amazon, of the vast boreal forest. We have to make sure the broader terrestrial and ocean sinks are operating in good condition. So it's going to be a pretty comprehensive effort to become much better stewards of the biosphere, as well as getting emissions out of our economic system.
I guess an addendum to that question about ocean acidity, do you include that in your evaluations?
Absolutely. The ocean acidity is an important issue, and of course that's increasing because of carbon dioxide emissions into the atmosphere, some of which dissolves into the oceans. An issue because it's eroding the ability of the ocean to take up carbon, because some of the organisms, the coccolithophores and other types of plankton in the ocean have calcium carbonate shells. And those shells are eroding, increasing acidity, which in turn decreases the ability of the ocean to take up carbon.
Okay, so when you say ocean sink, you're referring to things about temperature as well as acidity.
Yes, so we're looking at things that absorb carbon from the atmosphere into the ocean. One of them is simply solubility, dissolving CO2 in water, just as you dissolve CO2 into a soft drink and make a fizzy Coca-Cola, for example. The ocean can absorb carbon dioxide at a certain rate. But the second process is that the marine biosphere, the little phytoplankton, little creatures in the ocean, actually also take up CO2 just like plants do on land. And so there are two processes by which the ocean takes up carbon from the atmosphere.
Well, tell me if I'm wrong, but aren't phytoplankton the biggest source of carbon sequestration on the planet?
Yeah, the ocean in general absorbs slightly more than the land, but it's both processes in the ocean, the dissolution and the small plankton. Yes, they are very important in the carbon cycle.
You argue that social and technological trends and decisions occurring over the next decade or two could significantly influence the trajectory of the Earth system and potentially lead to conditions that resemble planetary states that were last seen several million years ago. Conditions that would be inhospitable for current human societies.
No, it's pretty much what I've spoken of. It brings together two things. One is this planetary threshold, this cascade of these tipping points. And what we're saying there is that we could actually trigger those in the next couple of decades. And if we do that, of course, then we would be on a trajectory or a pathway that would lead to conditions we haven't seen for millions of years. The best analog there for, say, 4 or 5 degree world is about 15 to 17 million years ago. There was a geological epoch called the Miocene, which was 4 or 5 degrees hotter. Sea levels were very much higher, anywhere from 15 or 20 meters all the way up to 40 or 50 meters higher than today. So that would be an extremely different world from the one we have now.
Wow. You're not talking about that happening in this century, are you?
Oh, no. But it puts us on a pathway that we can't get out of. That's the point. Yeah, we're not going to see tens of meters of sea level rise this century. That's simply physically impossible. But we can see rates of sea level rise as much as 2 meters or about 7 feet a century. A lot of our infrastructure is designed to last for a century. Harbors, a lot of our transport infrastructure along the coast. 2 meters sea level rise would be disastrous for many of the big coastal cities.
Yeah, international commerce might not exist, maybe? I don't even know.
It would be extremely difficult because, of course, most of the stuff that we consume gets shipped internationally is through these large container ships. It's not by air. So, yes, that would be severely disrupted by a rapid rate of sea level rise. So 2 degrees sits pretty much within that range, but the uncertainty around that could mean that threshold could be as low as 1.5, could be as high as 3 or so. But once you cross that threshold, say it's an essentially irreversible pathway driven by these feedbacks, by these dominoes that are falling over like a cascade. And that, of course, will eventually lead you to an Earth that is perhaps 4 or 5 degrees. A few people say even warmer than the pre-industrial temperature.
You say that crossing a certain tipping point could trigger an abrupt, nonlinear response. I mean, just how abrupt are we talking about?
When we're talking here, we're really talking abrupt in Earth system or geological time frames. Some of them might be reasonably abrupt in human time frames. Good examples of this are the erosion of some of the ice sheets in Antarctica, particularly in West Antarctica. Some of these marine-based ice sheets, in other words, they're ground under sea level, can be eroded relatively quickly, and over a matter of a decade or so, large bits of ice are being destabilized. We saw this with the Larsen B ice shelf and things like this. Arctic sea ice, that's decreasing at a very fast rate. And we think that in a decade or two, the Arctic could be completely ice-free in summertime. So that's one example of where we think a tipping point has already been crossed. In terms of the biosphere tipping points, again, they could happen pretty rapidly, mainly massive fires. We've had a couple of seasons in the Amazon already where a combination of drought and deforestation has triggered some pretty large fires, losing quite a bit of carbon. And in fact, in 2005-2010, we've had 2 such fires, and that's wiped out about a decade's worth of carbon uptake. So we're starting to see some of these processes, fires, abrupt ice loss, which are actually starting to happen fast, even on human time frames.
I just want to elaborate on that a little bit. Right now, our winter in Toronto, Canada, we have to wear a coat. Do you envision winters in this century getting to the point where we won't have to wear coats because it's so generally warm?
Well, certainly in northern high latitudes like Canada and Scandinavia, yes, this century, if we go to say a 3 or 4 degree temperature rise by the end of this century, winters will have shrunk, so there may be a month where you might have to wear a jacket or two. You'd probably go into October, November, December. You have some pretty warm days in November, probably shirt-sleeve days. A very short, mild winter, say 6 weeks or so, and so on. And you're already starting to see squeezing of some of the seasons around the planet. In southern Australia, we go from our winter time, which is becoming milder, and spring gets squeezed. So instead of having a couple of months of sort of nice in-between weather, we go from a little bit chilly weather, and then a couple of weeks later, we're hitting 30 or 35 Celsius, pushing 100 Fahrenheit. And that's happening in other parts. Sweden's had some incredibly wild swings in weather in the last couple of years. I think it's going to be more a destabilization of the patterns that we're used to.
Just to get on to the feedback processes, how serious a concern are these feedbacks? Let's break it down.
Okay, bacterial respiration, that's a new one that we've got to do some more work on. We don't know much about really what controls how fast this bacterial respiration occurs, but there's some recent research that suggests we've underestimated. So that's a new area we have to do more work on. Loss of sea ice is pretty well known. We've probably already crossed the tipping point, and most scientists think that we are now guaranteed to have an ice-free Arctic in another couple of decades. Changes in ocean circulation, sort of the poster child for that phenomenon is the so-called Gulf Stream, the North Atlantic circulation, which pushes warm surface waters all the way up past Iceland and Norway and keeps Scandinavia habitable for the moment. But that's part of a much larger ocean circulation, sometimes called the ocean conveyor belt, which moves heat around the planet, but also moves nutrients around the planet too, so it affects the marine biosphere. And changes in circulation there can have big effects. For example, on Antarctica, where if you get more warm water coming down from the Atlantic, it can erode some of these marine ice sheets in Antarctica. So there's a complex and interesting story around ocean circulation. Permafrost is really interesting because there's an enormous amount of carbon that's stored in the ground as frozen peat. That's been stable for about 10,000 years or even longer, actually. We're starting to see the first signs that this is being eroded up in eastern Siberia. There's starting to be some melting of that, some bubbling out of carbon dioxide and methane. So two gases come out of that. Methane is a very, very potent greenhouse gas. And when it goes up in the atmosphere, it's 30 or 40 times more potent than CO2 in terms of trapping heat. The good side of that story is it doesn't have a very long lifetime. About half of it's gone in 10 or 12 years. But it turns into CO2. It's oxidized up there. Anyway, there is something like 25 years of human emissions worth of carbon that's vulnerable up eastern Siberia. So it's activated an enormous amount of carbon into the atmosphere. Ocean methane hydrates, they're an interesting one. They're sort of similar to the permafrost. They're frozen carbon, but instead of sitting in the soil, they sit in shallow ocean sediments, so they're underwater. But they also can be destabilized. Our best estimate is it's going to take more than a 2-degree warming to destabilize them. But once you start destabilizing them, say at 3 or 4 degrees, there's even more carbon stored there than in permafrost. We did see an episode about 55, 56 million years ago when these methane hydrates were destabilized. We don't know why, but they caused a massive spike in temperature of about 4 or 5 or 6 degrees, similar to what we're looking at now. And it took about 200,000 years for the Earth to bring that temperature back down, which it did. But this is, some people are saying this is not a bad analog for what might happen with human-driven climate change.
I wanted to ask about, you said earlier about ocean circulation. Is it possible that the origins of hurricanes could be affected, where the hurricanes start and how severe they are?
That could be, but I think a more general factor here is the warming of the surface ocean. And warmer surface waters contain more energy. So that means that you're likely to see more Category 4 and 5 hurricanes than we have in the past. And indeed, in the North Atlantic, where we have long enough records, that has actually been observed. There has been observed increase in Category 4 or 5 hurricanes over the past 40 or 50 years.
I want to ask something about the permafrost and the ocean methane hydrates, which is the frozen methane gas at the bottom of the ocean. How vast is that compared to the CO2 pollution that we're putting out into the atmosphere right now? How big would it be if it all got loose? Do you have any figures on that?
Well, the figures I've seen are the ones that are quoted in the IPCC report, and that says that if we go on what's called a high emissions trajectory, in other words, if we do from fossil fuels at the rate we are now and go to a 3 or 4 degree temperature rise by the end of the century, that we could activate 250 billion tons of carbon. Now, that's an upper end estimate.
Could the loss of ocean circulation result in an end or even a reversal of the loss of ice since warm waters are no longer headed towards the Arctic?
I think what's happening there is you're going to get a regional internal feedback, because as that Arctic sea ice shrinks during the summertime, that's of course the time when the sun is shining over the Arctic, it uncovers dark ocean waters, and those surface waters are heating up, and they increase the air temperature over the whole region, which leads to more loss of the sea ice, which uncovers more darker ocean water, and you get an internal feedback within the region that's independent of the larger scale ocean circulation. So that no matter what happens to ocean circulation more generally, we are committed to losing the summer sea ice in the Arctic.
And that's actually not just the Gulf Stream, it's a worldwide kind of conveyor belt we're talking about, I believe, right?
Yes, indeed.
Yeah. Now, let's say that hypothetically just shut down. Around the equator is super hot, but it's actually cooler in the north and the south, right?
That's difficult to say because the transport of water horizontally. If you stop that circulation, you're going to stop the upwelling and downwelling of water that connect the surface ocean with the deeper ocean. If you stop the downwelling of warm water, that's going to heat the surface ocean even more. And if you stop the upwelling of deeper water, you're going to stop the provision of nutrients to the surface waters, which are going to affect fisheries, but which will also affect the plankton that take up CO2 from the atmosphere. So stopping ocean circulation would have many big complex impacts on the Earth system as a whole, and could well lead to actually an increase in warming by weakening the so-called biological sink, the phytoplankton and so on. So there's a whole lot involved with stopping ocean circulation. Nutrient provision is one of the most important ones. So I haven't seen anyone who's actually done the simulations, but it would be a pretty complex set of impacts.
Your report also states that changes in demographics, consumption, behavior, attitudes, education, institutions, and socially embedded technologies are all important to maximize the chances of achieving a stabilized Earth pathway. Could you break that down for us?
Yeah, some of these are pretty clear. Demographics is a good one. The global population are dropping in most parts of the world, but we definitely have to stabilize. But consumption, that's a big one. Again, there are some interesting trends occurring here, moving away from consumption of goods toward consumptions of services. And there's been some good work done by economists like Tim Jackson in the UK on how you build a circular economy that's much more based on services. We need changed behavior and going toward more social interaction, more emphasis on services, more emphasis on community rather than individualism and so on. We need to change our education away from wealth generation towards stewardship, toward managing our behavior with respect to the rest of humanity and the Earth system, and so on. Socially embedded technologies, again, this is some of the new stuff that's coming up in the so-called digital world in terms of transport like Uber that our new digital technologies are allowing. So basically what we're saying is that we have choices here, and we can sort of steer new ways of doing things towards stabilizing the Earth system. So it's a huge opportunity that's before us here. But it does take new values, institutions, and a system that steers our behavior and development toward the stabilized Earth. We need a better global governance system because this is a true planetary problem. The Earth system is one single system. We are one species, even though we have our differences. And of course, underpinning all of this are value systems that steer our economy toward less pressure on the biosphere and so on.
You speak of polycentric governance systems.
Polycentric means a number of different nodes acting as a network rather than a hierarchy. So we're starting to see that actually here in Australia. So as well, we have a national government, which is really a laggard on climate action. We're developing what we call a polycentric governance system at the local level, which is getting a lot more done on the ground. There's a big program that's been developed here called the Cities Power Partnership, where a lot of different cities are actually working with each other, sharing technologies, sharing ideas, jointly investing in renewable energies and so on.
Is it possible that climate change could send us into a kind of Mad Max world?
Yeah, look, it's an interesting question. And in fact, this Hothouse Earth trajectory that we talk about, the one you don't want to get on, could indeed be something that looks like a Mad Max world. And that's the sort of thing, obviously, one wants to avoid. But that would be the scenario where you get social breakdown, conflict, where you get groups of people just struggling to stay alive, and so on. It's a pretty dire scenario, and that's the one we certainly want to avoid.
You also mentioned global trade, investments, and finance. Could you say more about that?
Finance, I think, is something that's really needed to look at. For example, when you look at one of the big tipping elements in the Earth system, the Amazon forest, the really important one is the direct human pressure on that system through deforestation. But that's a huge pressure on it. Now, one of the big levers that we can use to control that is actually finance, because those companies that go in and do the clearing on the ground, they get their money from finance companies. So when you follow that back, you find that there are 10 or 12 major finance companies around the world that are the dominant players in the Amazon. So they could have a key role in this by pulling money out of any activity that's going to further deforest the Amazon. It's similar to the divestment movement for carbon. In other words, of finance companies pulling money out of new fossil fuel projects and so on. So what we're saying here is that the finance and investment sector has a really, really strong role to play here, whether it's investing in fossil fuel projects or whether it's investing in projects that threaten some of these big tipping elements around the Earth.
That's good. A little off book. I just wanted to ask, since we didn't say anything about eco-modernism, would you call yourself an eco-modernist?
I know there's an eco-modernist movement primarily in the U.S. There are others that say we should live much more simply with less technology and so on. There are others who have other approaches. So I think what we need is to have a discussion around this rich array of possibilities that are out there, because we certainly have to change the direction we're going in today. I think that's one of the hugely important topics that needs to be discussed. So whether it's eco-modernism or whether it's some other approach or a mixture of these approaches, that's yet to be determined. I'm within a group of people who call ourselves planetary physicians. So we're diagnosing what's going on. We can say what needs to happen with regard to the Earth system, but how humanity reorganizes itself to do that, I mean, that's really the ultimate question.
Well, we want to thank you very much for being on this show.
Okay, fascinating.
Okay, thanks, guys.
And now for our final thoughts. We hope that you have enjoyed this podcast, but we hope that you have not merely enjoyed this like a disaster movie, because the crisis that we face is quite real.
While most of us have never experienced worldwide catastrophe in our lifetimes, many of our fathers and forefathers have. A great part of the 20th century can be described as apocalyptic and could have been avoided.
The dystopian world that Dr. Steffens describes is nothing less than a ticking time bomb that needs to be diffused. The best advice that Dr. Steffens gave us is that environmentalists of all stripes need to engage in real and deep conversation. A real conversation is something that occurs not on Facebook, but face to face.
A real conversation is when we speak to each other as equals.
A real conversation is when we talk to each other and not at each other.
A real conversation aims not merely to teach, but also to learn.
But conversation alone will not change things. Talk is cheap unless it leads to action, and the time to act is now. And that's it for our show today. This is Gabe Bignetti.
And this is Rick Maltese.
We'll be signing off till next time.